All right, so we're going to talk a little bit about friction. And friction is a force that opposes motion. There's kinetic or sliding friction, and so that's what's acting on something that's already moving. And static friction is that friction on an object that is standing still that you're trying to get moving. So if you imagine pushing on a couch or trying to move some big furniture, that first push, it takes a lot to get it moving. And then after it's moving, it's a little bit easier to push. That greater force needed to get something moving is used to overcome static friction. And then the smaller force is to overcome the kinetic friction. And it depends on the material that is in contact. So it's the two surfaces of the objects, what the material is made out of, and also the roughness of the material. And it also depends on how tightly the surfaces are pressed together. So the more you press them together, the greater the friction will be. And so if you look at surfaces at a microscopic level, different materials have different roughnesses. This should make sense to you. Something that's very, very rough, it's harder to move something across. You can think about tires with the treads on them. They're created to create greater friction than a smooth tire. And when you're looking at the roughness of the surface, it should also make sense that if you're using a lubricant like graphite or oil, it kind of fills up those surfaces and smooths out the roughness, and that is going to decrease the friction. So to decrease the friction, if you don't have a lubricant, you can move the surfaces farther apart or make them press down on each other less. So static friction, like I said before, keeps surfaces from starting to slide, which is, we like that. Things stay put where we put them until you start to move them and overcome the static friction that is keeping them in place. It's greater than the kinetic friction. And so kinetic or sliding friction, it's going to slow down a moving object. And then if you get around to the idea of something that's rolling, like a wheel or a ball, that's actually static friction that just keeps changing. So it sticks, and then it forces the object to roll to the next spot of contact, and it sticks again, and it forces it to roll, and it sticks again. And of all of these frictions, when you're talking about the ability to stick to something, we often use the word traction, and that refers to the greatest amount of friction at a given point in time. So this is kind of a diagram of what's going on with the rolling friction. The friction, so here's a diagram of what's going on with rolling friction. So you have a wheel and it's sitting on a surface. And as you push on the wheel, the static friction is going to resist the sliding, and it's going to cause that wheel to rotate. So it's acting with a torque. And then you push again, and the wheel rotates, and push and rotate, push and rotate. So this just keeps going, and you end up with the idea of a rolling wheel. So let's talk a little bit about the friction and energy transfer. We talk a lot about conservation of energy and the idea that energy can't be lost or destroyed. So what's going on when that energy is being worked against by friction? And what will happen is some of that usable energy turns into heat. And once it does that, you can't really recapture it. It just goes out in the air. So it's no longer contributing to doing work or making the object move or slowing it down or doing something useful. And static friction really is more efficient in that it's always in contact with the surface and it's always making things work. There's a little bit of loss here and there, but it's sitting still, so there's no friction causing heat. There's no friction making noise. It's just sitting there and it's still. So hopefully this helps you with what friction does and how it interacts with the ideas of conservation of energy. Alrighty, bye-bye.